Hey, Guildies, Fletch here. Today we're going to talk about simplicity, the art of maximizing the amount of work not done, and how that's essential. So let's jump into that. All right. So I think this is very apt that this is number 10 and comes after number 9, because number 9 essentially says do software engineering, and go watch that video and everything I say about that. It's essentially saying these higher level, these principles, these best practices, these platform concerns, cross-cutting concerns, and these ideas that are, software engineering. That's very important. It enhances agility. And then this one's saying, don't over-engineer. Now you have to put this in here because some people might read this and they might read this as over-engineer. Go and just focus on only engineering. But a good software engineer is going to know where that balance is. So this could also be like the don't be a tryhard um, uh, principle. And the idea is that you could be maybe over engineering or practicing engineering as a software developer with a few years under your belt, and you're doing these engineering things that are higher level, doing higher level thinking, and learning principles and best practices, and you're testing your limits. You're pushing your boundaries, and so you could be over engineering. But once you get to that level of, yes, I'm a software engineer, I know where that balance is, then that's the point. You don't really need this as a software engineer who's at that level already. So this is a good thing to sort of hold you back and tell you it's not purely software engineering and platform level stuff and abstractions and all that sort of stuff. Uh, you know, this is very important to hold a developer back from going too far. So that's one way of seeing this. The other way is the business. The business needs to understand that you will overcomplicate your code by adding features or planning features or getting this big feature list and always talking about different features and what's up and coming in the down the pipeline, and this is the big idea, and putting the vision on the developers, because you're gonna just make your code spaghetti, a big ball of spaghetti. And why are you planning all that out and putting this all on the table and making everything get worked on at once when you're not getting the feedback from the customers, from the stakeholders? So this is another poke at the idea of keep it simple, focus your plans on the current work and only slightly into the future. Don't focus on anything beyond slightly into the future and what's currently being worked on. Make sure you're getting that feedback from the customers, and this is what the developer should be focusing on. Also, don't value developer metrics. If you're a business and you're looking at dev metrics in order to see how much is getting done and saying we need to make sure a lot's getting done and make sure that these amount of story points are getting done and stuff like that, then you're not looking at the right thing. Your metric as a business owner or as an executive on the executive side should be, what are the users saying? What is the feedback coming back from the stakeholders? Because that's your real metric. That's your metric of success, is feedback from the stakeholders. Um, so that's the business. And then also, you could call this the TDD principle, because as a developer, you can follow this principle almost perfectly by following TDD. And TDD is not writing a unit test before writing a small unit of code. Maybe in a small sense, let's start with that principle. But TDD is also, it could be more broadly defined as writing a test for the level of code that you're doing. So if I'm making a new API endpoint, I need to create an acceptance test. Or if I'm integrating with a new third-party SDK or something like that, I need to make an integration test. I need to do a small test, and then I need to implement that bit of code. It's mostly applied, for simplicity of thinking, to unit level tests that are just, this is my unit of work. It's usually functional, like functional code, or code that is mostly functional but needs to have some things mocked out or something like that. So that's usually where TDD is applied. But at a higher level of thinking, TDD is every bit of code that you're going to be putting out there, even framework level code or platform level code, needs to have a test written first. And if you do that, if you follow TDD, then the idea is you write a small amount of code that defines the specification or the requirement for just one little bit of it, not the whole requirement for the feature you're doing. Just, this is one little thing it needs to do. one acceptance criteria, one use case, one something. Let's put a little test for that. Let's put a little functional test for that, regular TDD, and then write a unit and iterate on that, do a little bit more. And okay, we need to expose this as an API. Let's create an acceptance test. Let's create a regression test. Let's create an integration test, whatever the test is for whatever the thing that you're doing. And then let's go do a little bit of implementation and let's iterate on that. And we'll refactor, we'll write a test, we'll implement just the amount of code necessary to make that test pass, and then we'll refactor and we'll iterate on that until everything passes and everything's done. That's the idea of TDD. And it can be done in legacy code bases and it can be done in greenfield code bases. And I want to get into a big discussion on how that works. So simplicity, the art of maximizing the amount of work not done is essential. One last point of this is these are developer principles. This is the Agile Manifesto for software development. This is very much related to software development. This doesn't really work for things like surgery or building a bridge. Or a new skyscraper or something like that. In those cases, you need to plan, get everything down to the wire and know exactly what you're going to do. You still want to minimize the amount of work done. But in those cases, you need to plan out everything because you've got one shot at it. You don't build a skyscraper and be like, it fell down, let's go ahead and rebuild a skyscraper. For software development, you can do that where you build one little bit at a time. It's not a finished product. It's not done. It might have a bug and you iterate and you iterate and you iterate. So this really only works for software development. But that said, this doesn't mean go develop code because the art of maximizing the amount of work not done could mean that feedback comes from a customer and you say, we don't need to program a thing to fix that. It's sort of by design or it is by design, or it's not a problem that we need to solve in code. This is a training problem, or this is something where we need to update the FAQ, or this is something where we need to get even more feedback to make sure we know what we're doing here. A lot of times this is the don't develop anymore. Stop developing and let's get some feedback and let's figure out a different solution principle. So that's the art of maximizing the amount of work not done. Like and subscribe, leave a comment. I'm going to cut it off. Hopefully this was short. I'm going to cut it off to keep it simple. So thanks for coming.